Hello. In this video, I'd like to highlight some of the topics that we're going to cover in GEOG454, the spatial simulation. In this course, we mainly cover two types of spatial simulation. The first is environmental simulation. The second is spatial simulation. The environmental simulation mainly deal with physical environment, such as flooding, erosion, pollution, wildfire, hurricanes, tornadoes, so on, so forth. There may possibly many other topics, but I just mentioned a few examples. First, let's look at this example of erosion. Now, this obviously is a landscape. You have elevations, the dark area indicates mountainous areas, lower, and then blue areas is water bodies. And I can start running the program and let's let it go. You can see with the time ticks, and then the erosion take place. And over time, places with high elevation will be cutting down, and where the water bodies begin expand. Okay. And so that is one kind of models you can run to create this kind of erosion model. Then I show you another example. You can also do, this is an example of tornado. So I created a physical landscape. So every time you run it, and the physical landscape kind of occurs with a brown air color indicates some mountainous areas, and the green and lighter color indicates some kind of a flat land. Then you let it go, and you can see that there's a tornado begin running around. So that's and basically it stay on the ground and not get on with a high elevation area. That's the reason. That's why the tornado alleys is basically in the places where you have relatively flat area and low elevation. You can also turn on this a device to show what the damage has been done by tornadoes. Now you can see areas that has been damaged by tornadoes can see clearly now. So this is some stuff we can do with environmental simulation. Now let me show you something else. Okay, this is we can simulate wildfire. Look at this wildfire. I'm going to set up the wildfire. First, let's not have any kind of devices. We just have the forest. With the forest, and we can set up some kind of a random wildfire site and let it go. You can see that because of wildfire, it is spread in the forest area. Okay, you can also use a slider to alter the density of the forest. And now I reduce the density of forest, and we have 6 wildfire sites, and now let it go. You can see that the wildfire did not really spread that much. Now let's increase the forest density to 60%. Okay, and now let it go. You can see it's increasing in forest density, more conducive to the spread of wildfire. And of course, not all places is burned. Now 74% of forest has been burned. Now let's increase to 10 wildfire location and set it up and let it go. Now, because we increased the number of random wildfire site, this time, keep going. Okay, this time 74% of what forest has been burned. Now let's increase the forest density a little bit, increase from 60 to 65%. Set it up, let it go. Okay, so you can see that this time the wildfire go a lot smooth, and now 94% of forest land has been burned. Now let's look at we can increase some kind of a wildfire prevention breaks. That is, we cut some of the trees in some zones in the forest, so that we create those kind of breaks in the forest. Use those breaks to prevent the spread of a wildfire. Again, same forest density and same 10 random wildfire site, and let go. So now, because of those breaks, you can see that they effectively stopped the wildfire spread to all corners of the forest. This time, we only have 62% forest has been burned. Now, let's increase the forest breaks more. Now, this time, we have more forest breaks. Same forest density, same 10 a random wildfire site. Let's go to see how that will change the way the wildfire spread. Now, only 19.4% of forest has been burned. So that is kind of give you a sense of the kind of things that you can do with environmental simulation. Now, let's. This is a very simple model that I try to use this model to simulate cyclones, the hurricanes. You can see that it start running, and you can this low pressure cells that are spread from the southwest corner of the ocean moving toward the northeastern corner of the ocean, and you can really see how the clouds forms, and that is the clouds fall into, will suck into the low pressure cells in the middle. So that's how this kind of stuff you can do. Now let's go to something more interesting. Let's go to look at we have seen. Let's look at some of the some other wildfire model, and this is a model that I like to show you. Let's see this one. This one. Okay. Let's see what is this model. Oh, this model is a pollution. This is a pollution model. So this is a shore side. So you can have this, you can use the slider to decide, I'm going to have a two-point pollution on the shore, on the lake shore, and 3 inland point pollution here. So you can see these 2 points indicate the lakeshore point pollution site. Every time you click the setup button, you can really have randomly generate this lakeshore pollution point and inland pollution point. Now you let it go. So you can see the time ticking, and the pollution point begin to work. And over time, you can see that those pollution spots increase in size. Here is an inland pollution spot. Here is another one. Here is another one. And here is one lakeshore pollution that has gone into the water. Okay, so that's something you can do by simulate, by mimic how the pollution is spread. Okay, now let's look at another model. This model is for testing pollution. This is look at this. Okay, and see what is okay. This is we have seen. This is simply that a erosion model. So I'm looking for. Let me show you this this model. Okay, the pressure system. See this in this model. I first set up this kind of a physical landscape, this is the land, this is the ocean. On the land, there's a little bit mountainous area here at this corner. And also you can show the temperature and the pressure system. And when you let it go, you can see on the land, for example, in the summer, you have a higher temperature. So on the land, you develop a low pressure system. On the water, you develop a high pressure system. And the air will suck into the low pressure system and air coming out from high pressure system. So you can really simulate the pressure system on land and ocean. Let me also show you something else. You can also show seasonal changes. Okay, this is a model that I use to show seasonal changes. Okay, with same land and ocean, and I can show the temperature, pressure system. So I let it go. You can see that here we have seasonal changes. The different seasons, the blue cells, high pressure, and the red cells, low pressure, may occur on different location, either on the land, either on the ocean, really depending upon the temperature and pressure system that occurred at the different season, and also on the land or ocean. So that is something that you can really simulate the dynamic change in the pressure or not. Again, season changed, therefore the location of high and low pressure system will change as well. So this is something that you can really do with this kind of a model. Let me stop this. See something else we can do the and see there's another model I like to show you that not this one. This let's see whether I have show somewhere else. Okay. This is a model that attempts to show how we can simulate. Okay, let me see. Okay, this is a kind of wildfire. The wildfire. This is a wildfire that we have several spots that experience wildfire, but wildfire is somehow influenced by the land use as well. Okay, for this model, I first want to set up how many wildfire spots. Let's use 3 spots, 3 wildfire points. So I set it up. So you can see that there are 3 places that you have a red spot for. Okay, and again, okay, 1 point here, 1 point here, 1 point somewhere else, and we let it go. And the wildfire, you can see that over time, you can see that the wildfire began to expand. This red point will put there to make it clear that this is where the wildfire is burning. So you can wait until the spot become larger. You may wonder that why this wildfire point seem to grow a lot faster than this wildfire spots. Because when we set it up, you can see on this slider at the bottom, there's you can alter the weight of grass, forest, what is their contribution to the pace of wildfire spread. Now I said the contribution of the weight of grass is very heavy, 95%, but the weight of a forest is only 6%. Therefore, in places where you have a lot of grass, that's where you have the wildfire spread very fast. Now, to make it clear, let's go to see the map that show the grass. You can see that on this map, darker color area has a lot of more grass, and lighter color area has less grass. That's why you can really determine each of those factors that contribute to the wildfire. So you can alter the weight of different factors. Now let's change. Let's reduce the weight of grass, increase the weight of forest. Let's see what happened. Okay, but now again we set up some random. So now 3 points here. Let's look at the forest map. On this forest map, see on this map, all the light color areas you do not have a whole lot of forest. The dark color area has more forest. So now let's change the random, reset this random spots so that we could have some spots that occur in places with heavy forest. Again, not quite. Reset it again. Let's see. Do we have places with heavy forest? No. Let's create again. Try reset again. And reset again. Okay, you see this spot now occurred in forest. Let's reset one more time to see whether we can have okay, this place seems to be occurred in forest, heavily forest area. Let's do one more. I just try to create a situation where you see clear contrast of the control of wildfire by selecting places with heavily forest area and lightly forest area, so that we can see how variation in forest may contribute to different pace of spread. Okay, this spot obviously occurred in places with heavy forest. Now let's go. Okay, let's see how wildfire grow in places with or without heavy forest. Okay, because now we reduce the contribution from grass, we increase the contribution from forest. So we would expect that in places where you have a heavy forest, the wildfire will grow, will spread much faster than places with lighter forest. Okay, so look at this point. This point now grow a lot faster than the wildfire at this place because this spot is at the place with high heavily forest. Okay, it's clear. So now you can. So this is kind of a simulation that you can put in the control by looking at the control the weight of different factors, and that is make the simulation more realistic. You can even collect the real world data to make those control values more realistic. Okay, so now let's stop this. So now let's look at what is the contribution from temperature. So I reduce the weight from forest, from grass. I would increase the contribution from temperature. Now let's take a look at the temperature map. This temperature map. I think on this map, the darker color is where places you have a higher temperature. So again, I'm going to set up this several points so that we could have a point that occurred in temperatures of different value. Okay. I'd like to put some point over here and put it here as well, so that they could occur. Okay, here is you look at the temperature map. So this is a point that occurred in the lower temperature area, and these are 2 points that occurred in a higher temperature area. So let's go. So we would expect that these 2 points, the wildfire grow a lot faster than this point. And that goes because the heavy contribution from temperature. Okay. Now you can see there's a little point here. With this point, I try to simulate the wind, the direction of the wind, because the wind will also contribute to the wildfire. So now it's clear that in the 2 places where the temperature is higher, the wildfire grow a lot faster. So this is a really kind of a study, a kind of modeling that we can do. This kind of spatial, or there's some kind of glitches. This kind of environmental simulation, because it come to the edge here, it run out of this run out of space. So that's why I give you error messages there. This kind of simulation, I use this software called NetLogo. NetLogo is a open source software for simulation. And to do this simulation, you would need to use this script. You can learn to write a script. But the NetLogo script is relatively easy to learn. So in the course, we first spend some time to get familiar with this program, to learn to write the basic script. Then we can get on with actual modeling. So these are the few examples that I showed using environmental simulation.